All right, let's take another question to understand the topic we discussed in last one, that of antilogs. So we discussed that the procedure to take antilogs is just considering the logarithmic equation and applying base both the sides, and then invoking this property which just says that if these two bases match, they cancel out each other. Log and exponential function of same base, they cancel out each other, so we are left with x. So when we apply this base b both the sides, this thing will cancel out and this x will come down, and we'll get our solution, in which case we were trying to remove logarithm. So logarithm has been removed. So that this algorithm is what we call as taking antilogs, and we need the same thing in this problem. So let's work this out. So we see that we want to solve this equation for x. That's our question. Let me write it down here. So we need to solve it for x. So we need the value of x here. And the equation has two logarithms on it, and we need to pull out this thing. So for that we need to remove these two logarithms, since this is outer log. So we are going to break this one. So we'll apply base 7 both the sides. So we start with this. We are given this equation, log base 7 log base 5 of square root of x plus 5 square root of x. This is 0, and I'm going to use base 7 both the sides. So since I'm using 7 as base, let me pull equality down a little bit. So now this is equation 7 raised to power this is equal to 7 raised to power 0, because these two things are given to be equal. So because they were equal, we have just placed base under them. And then we have this property. Again, we are going to invoke that. B raised to power log x base b, that should be equal to x. So in this case, we see that these two things will cancel out. So we are left with log base 5 of square root of x plus 5 plus square root of x. And on the other side, we have 7 power 0, which is 1. So this is, so now log base 7 has been removed. So now comes this log. So again, what we are going to do is we are just going to place another base here, and that's going to be base 5. Equality will be pulled down, and in that case this will cancel out under the same property, this property. And so we have successfully isolated x, and 5 power 1 is 5. So now we can just square it up, and before doing that we'll just take this square root x on the other side, and now just squaring these terms, we get x plus 5 should be equal to 25 plus x minus 10 square root of x. So that just means that minus 10 square root of x, this will cancel out, and we get minus 20 the other side. So root x should be equal to 2, which just means x is 4. Right, so that's our answer, and we can verify it quickly. So we see that if I place x to be 4 here, then I get square root of 9, which is 3, and square root of 4, which is 5. Square root of 4, that is 2, and 3 plus 2, I get 5. And log 5 base 5 is 1, so this is going to be 1. And log 1 is 0, so it satisfies the equation perfectly. Right, so a very simple problem, just a basic application of antilogs. So, all right, so we are done with this. Logging out. Bye-bye.